Hey everybody, it's Jane from Norman is Right. A couple weeks ago, I talked about building pressurization, and I think it'd be good to do a follow-up and answer the question, what is stack effect? So let's get started. Stack effect is the movement of air into and out of buildings due to air buoyancy. Buoyancy occurs due to a difference in air density that results from temperature differences between the inside and outside of a building. So let's move this over and draw a building and make it a few stories high. Hot air is less dense than cold air, so hot air in a building will want to rise to the top of the building. Stairwells and elevator shafts contribute to the stack effect as hot air rises up them. The airflow leaving the top of the building creates a negative pressure that will draw air into the building. This air can come in through doors, windows, and other cracks in the building. This is called infiltration, and the air leaving is called exfiltration. Let's move this up. The stack effect increases with the height of the building. Taller buildings have a stronger stack effect, and it increases with the temperature difference between the inside and outside of the building. Stack effect happens all day, every day. In the winter, this can result in a lot of wasted energy. But it can happen in the summer. It's just usually not as bad because the temperature differences are usually smaller than in the winter. So let's go back up here a minute and let's duplicate our building. This one is winter and this one is summer. And move over a little bit. In the summer, you get a reverse stack effect because the air inside the building is colder and denser than the outside air. In this case, warm air is drawn into the top of the building and cold air exits out the bottom. Let's move this up. You see the stack effect in office towers with doors that suck open in the winter, and in high rises where lobbies are cold, but the floors above are overheated. Stack effect is one of the reasons that revolving doors were invented. When high-rise buildings were first being built, the stack effect caused so much pressure that air rushing in was making it hard to open doors. Stack effect can also cause comfort problems in a building because it may be hard to heat lower floors due to the cold air being drawn into the building. Let's move back over here. In a building, there's a point called the neutral pressure plane, the NPP. Below the NPP, outside air is drawn in, and above it, inside air is pushed out. This would be for winter. The opposite would be true in the summer. Where the NPP is located in a building depends on the distribution of leakage paths, the building height, and the difference in temperature between inside and outside. If the leaks are evenly distributed top and bottom, the NPP often ends up near the middle of the building. In reality, since most leakage is at the top due to the roof, penthouse, mechanical rooms, and at the bottom from lobby doors and loading docks, the NPP often sits somewhere above the halfway point, closer to the middle to upper floors. HVAC pressurization strategies can shift the NPP to a more manageable spot, and the NPP can help in troubleshooting air leakage, moisture infiltration, and even smoke control in fire protection design. So let's bring all this on screen. To minimize stack effect, you should minimize air leakage into and out of the building. Also, for most buildings, you should supply more air into the building than you're exhausting from the building to keep it slightly positively pressurized. HVAC designers have to account for stack effect when choosing pressurization strategies, sizing systems, and working with the building envelope. A well-sealed building with proper pressurization can save energy, improve comfort, and avoid air quality problems. So that's the stack effect and what can cause it. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.